Have you ever noticed that when a batsman hits a cricket ball perfectly, there is no vibration, no pain in the hands, and the shot travels far and clean? But hit the same ball slightly above or below that point, your hands sting, the bat vibrates, and control is lost. That magic point on the bat is called the center of percussion. In this video, we will deeply understand what is center of percussion, why it exists, how it is different from center of gravity, its mathematical expression, and its powerful real-life applications. This is Chapter 4 of Properties of Bodies, so let's begin. The center of percussion is the point on a suspended or pivoted body where a sudden impact produces no reaction force at the pivot or support. In simpler terms, when an object is free to rotate about a point and you strike it at a specific location, the pivot does not feel any jerk or shock. That special location is called the center of percussion. Imagine a uniform rod, suspended or hinged at one end, free to rotate. Now you hit the rod. Near the hinge, strong reaction at hinge. At free and strong vibration. At one special point, no reaction at hinge. That point is the center of percussion. To understand this, we must look at two simultaneous effects. Translational motion. The entire body tends to move forward due to impact force. Rotational motion. The body also tends to rotate about the pivot. At the center of percussion, the linear reaction force and the rotational reaction force cancel each other at the pivot. That is why no shock, no impulse, no reaction force at the support. Let's keep it simple and exam-friendly. For a rigid body pivoted at a point, distance of center of percussion from pivot equals cop equals I slash, where I equals moment of inertia about pivot, m equals mass of body, k equals distance of center of gravity from pivot. Special case, uniform rod pivoted at one end. For a uniform rod of length L, moment of inertia about one end, I equals ml caret 2. Distance of CG from pivot, k equals L/2. Substitute, cop equals / equals 2L/3. Result, center of percussion lies at 2L/3 from the pivoted end. Center of gravity, point where weight acts. Exists for all bodies. Related to gravity. Fixed for a uniform body. Center of percussion, point where impact causes no reaction. Exists only for pivoted / suspended bodies. Related to impact and rotation. Depends on pivot position. They are not the same point, except in special cases. Sweet spot equals center of percussion. Clean hit. No vibration in hands. Baseball bat. Players instinctively hit at COP. Maximum energy transfer. Hammer. When hammer strikes a nail perfectly, your hand feels minimal shock. Door. Push near the handle, not near hinges. Less effort, better rotation. Industrial machines. Shafts, levers, and rotating arms. Cop used to reduce vibration and bearing load. As a mechanical engineer, understanding cop helps in machine design, vibration reduction, shock-free operation, longer equipment life. You can show a ruler suspended by a string. Tap at different points. Observe vibration at support. Identify the zero reaction point. This makes the concept visually unforgettable. Center of percussion is a dynamic point, not a weight point. It depends on mass distribution and pivot position. It explains why some impacts feel smooth and others painful. Extremely important in sports, machines, and mechanical design. Definition: point where impact causes no reaction at pivot. Exists only for pivoted bodies. Cop is not equal to cog. For uniform rod pivoted at one end, cop equals 2L/3 from pivot. This was Chapter 4, Center of Percussion from Properties of Bodies. In the next chapter, we'll explore dynamic forces in rotating bodies. If this explanation helped you, like the video, subscribe to SimpleGAN, press the bell icon. Because engineering becomes easy when concepts are clear.